A lot of folks going into psychology are planning on heading towards the clinical area. They look forward to getting their patients on a couch and having them spew forth their issues and afterwards giving them sound advice on how to fix said issues. They like to help people, they like the salary, and in many cases, they like that there is almost no math involved. While I can admire this and it sounds interesting, my passion in psychology lies in research. Although I was unaware of it when I made my choice to pursue research psychology, math is essential to good research. In fact, as Dan Keltz taught me in Psych 250, a majority of master's and doctorate level psychology classes will focus on one particular branch of mathematics, statistics. Psychology relies much heavier on descriptive over numerical data. Think about it. Have you ever seen an insane, a depressed, or an excited? Well, we may have seen people exhibiting these traits. The traits themselves are something we can't see. Thus, we have to come up with a way to numerically represent these ideas and compare them. This is where statistics come in handy. In psychology, we study behavior and the things that affect it in order to make predictions. One such thing that affects behavior is intelligence. Although intelligence can't be seen, it has been quantified using the IQ test. When the test was administered, the score that was the mean was set as 100. What's the mean? Glad you asked. The mean is the first main term we'll want to discuss in our basic view of statistics. While this formula might look complex, the mean is a formula that we've been learning, sometimes as the average, since grade school. Basically, all that this means is that all of the scores are summed up and then divided by the number of scores presented. Voila, there's the mean. In this beautiful bell curve, the mean is represented smack dab in the middle by the giant hump over 100, the mean score. In the example of IQ, 100 is the most common score. As scores get less common, the curve lowers and lowers. As you can see, 50% of all scores fall between 90 and 100, whereas only a combined 4.4% fall below 70 or above 130. This is useful in making predictions. If one needs to take a shot in the dark about an IQ score, consult the curve. If you suggest that the IQ is 100, you'll be within 10 points of the correct answer 50% of the time. While it may not be absolutely ideal, it's much better than shooting at the score completely blind. The next term to discuss is standard deviation, which is a little more complex. Standard deviation is the square root of the variance, which itself is the sum of squared deviations divided by the number of scores. A squared deviation is the difference between the deviation from the mean in each score and the mean squared. When all of these squared deviations are found, they are subsequently divided by the number of scores presented. This is the variance. Then, the square root of the variance is taken, and ta-da, you get the standard deviation. Get all that? Standard deviation can be very useful. It shows where things begin to get less and less likely to occur by coincidence. For example, in looking at this chart, 68% of the scores are within one standard deviation of the mean, 95% within 2, and 99.7% within 3. Two scores that one is comparing in a study are 3 deviations away from the mean. There is very little chance that this has occurred by coincidence. The last term we'll discuss is correlation. A correlation is a comparison of two variables. It's a somewhat tough concept to explain mathematically, but in layman's terms, it shows how variables are related, either positively, with one going up as the other goes up, or negatively, with one going down as the other goes up. In psychology, anything above a 0.3 correlation is something you get excited about, while a 0.8 or a 0.9 correlation is simply incredible. Correlations can come up very easily in IQ. For example, studies have shown a staggering 0.92% correlation in IQs between identical twins. It is indeed no coincidence that Fred and George Weasley have IQs of 134 and 140 respectively. These are just some of the reasons and ways that statistics are important to research psychology. While they aren't the simplest branch of mathematics to understand, they are fascinating and, in my opinion, well worth the time I'll spend studying them.